Number 27, explain why the neutralization reaction of a weak acid and a strong base gives a weakly basic solution. Okie dokie. So the first thing here is that we have to write out some type of neutralization reaction in order to figure out why this scenario would give a weakly basic solution. Now, when you're doing a neutralization reaction, just know that it's just two compounds being added together. It's got to be an acid, and the other component has to be a base. They're setting us up here for what we exactly have to do. We have to pick a weak acid, and then we have to pick a strong base. Well, there's 6 strong bases in this earth, so just pick any one of those 6. It does not matter. So whether you pick, I don't know, NaOH, that's part of the list. If you want to pick KOH, that's part of the list. LiOH, CaOH2, it doesn't matter. Let's just make it a little easy on ourselves. I guess we'll pick NaOH, right? Everybody generally knows sodium hydroxide. Now, a weak acid, you just have to pick an acid that is not one of your 6 strong acids. So I can't pick any of those 6, but you could pick any other acid. Let's see. We could pick maybe NH4+, that's generally weakly acidic. We can choose a neutral one, like HCN. Maybe we'll go with this one. So for my example, we're going to have HCN reacting with NaOH. Okie dokie. So we have the acid, which is HCN, plus the base, which is NaOH. Now, generally speaking, what we would do is we would do just an exchange of the hydrogen, right? Generally, the acid always gives this hydrogen to the base. But NaOH2 would look really weird. So there's 2 things that we could do here. When you're dealing with metals, the first thing I would do is I would do a double displacement just to see what your products are in terms of a double displacement reaction. Now, remember, this is going back to, when we first learned how to balance equations. When you're doing double displacements, remember, outers go with outers. So in this case, outers go with outers. So HCN, the break is here, right? We should know where our polyatomics are by now, I hope, right? And between NaOH, the break between the 2 ions is right here, Na and then hydroxide. So outers go with outers, and I guess we'll color clash, but just to, make a point here. Inners go with inners. So your new compound is going to be H coming together with OH, and Na coming together with Cn. So let's do, I guess, the inners first. Doesn't really matter. So remember, these come from your ions. So this will kind of be like a review. Na was a +1 charge, and Cn is a -1 charge. Since they're both 1s, the compound would just be NaCN. Okay? And now, plus, let's make the other compound, right? H and OH. H is in group 1 on the periodic table, that's a +1, and hydroxide is an OH minus. So same exact idea here. H +1 and -1. So H2O. Now how did I get that? I shouldn't have skipped the gun here. It basically was HOH, right? But if we just group together the hydrogens, there's 2 of them, and that turns into H2O. Okie dokie. Now we can find out the answer from here. Now, we did see that we had a strong base, right? And the idea here is that when you have a strong base, the conjugate that it makes is always going to be so weak that it's considered neutral. It's easier to classify it as neutral. The idea here is that the stronger the base, the weaker the conjugate acid. So if you have a strong base, your conjugate acid is going to be so weakly acidic that it's just easier to say that it's neutral. Now, out of these two, which one is the neutral one? Water, right? We should know that water is neutral. So this would basically hook up with the water, right, as its conjugate. So the water has nothing to do with being acidic or basic. It has no bearing. But remember, this is supposed to give a weakly basic solution. If it's not the water that's making it basic, it's got to be this guy. And let's see if it makes sense. NaCN basically came from HCN. They both had the CN. And remember, HCN was a weak acid. So when you're dealing with weak acids, the conjugate is not going to cancel out. If you're acidic to start with, your conjugate is going to be basic. So this weak acid, HCN, will turn into a weak base conjugate. But the idea here is that if you start off with the weak acid, this will not be neutral. And since you're started off with an acid, the conjugate is always a base. So this is the bearer of that weakly basic solution. It's because you formed a weak conjugate base from your weak acid. And that's all. Hopefully this helped. Let me know in the comments. Thank you so much for viewing the video. And I will see you all in future lessons. Let's keep studying hard. See you later. Bye-bye.